Welcome class sa lesson number 3 natin ngayong second quarter sa Earth Science. In this video, I will talk about magma formation. Sa nakaraang video, we discussed about the Earth's internal heat. So this heat have resulted in the existence of different processes happening in our planet. And one of this is magma formation. Now, magma is defined as a molten or partially molten rock which is stored under the Earth's surface. And if this reaches the surface, then it will be called or referred to as lava. Special conditions are needed for a magma to form. So aside from the presence of the needed material, which is the rock itself, the following are also needed. First one is the decrease of pressure na nangyayari sa mantle natin and sa crust. Next, um, the addition of volatile materials to hot rocks, and the transfer of heat from magma that is rising from the mantle into the crust. So there are three special conditions needed for the formation of magma. Now, two processes are referred to when we are talking about magma formation. The first one is decompression melting. Sa decompression melting, it is the process of creating magma by the reduction of pressure at a constant temperature. In essence, constant yung temperature mo, mataas yung temperatura mo, pero magkakaroon ng pagbabago, bababa yung pressure. So instead of the material um, constantly in solid form, dahil bumaba yung pressure, magkakaroon ito or magbabago into liquid or a semi-liquid. Next naman is flux melting. So this occurs because of the introduction of volatile materials. So this volatile material could be water or a hydrous mineral. So in this case, it will cause chemical reaction dun sa mainit na rock which will turn this rock into or will melt this rock and will turn it into liquid or a semi-solid. Magma formation is common in the following locations. So dito, sa Rift Valley, sa oceanic or mid-oceanic ridge, hot spot or mantle flumes, and sa subduction zone. This one is also a subduction zone. So now, sa Rift Valley, ang nangyayari is decompression melting. In a sense, habang naghihiwalay yung dalawang continental crust, umuonte or bumababa yung pressure dito mismo. So as this pressure is decreasing, the rocks which is in solid form will turn into molten rocks which will be called or referred to as magma. Same thing is happening sa oceanic or sa mid-oceanic ridge. Decompression is happening. So as the two oceanic crust are diverging, nagkakaroon ng decompression, bumababa yung pressure, and then magma is forming. Sa hotspot naman, ang idea kasi ng hotspot, directly nagmumula sa mantle yung init that will produce magma. So, at hindi katulad nung ating nangyayari dito sa mid-oceanic ridge, mas malalim yung source ng heat sa hotspot. So, mas direct, which will directly, dahil sa init na to, dahil sa increase in temperature, magkakaroon ng magma formation. And of course, meron pa ring onting decompression melting na nagaganap. Now, subduction zone. Sa subduction zone, ang common is flux melting. So habang nagsasabdak yung oceanic crust, bumababa yung oceanic crust under a continental crust, ang nai-introduce ang water sa ilalim ng lupa natin. So as water is introduced, the hot rocks will be melted because of flux melting, which will in turn form magma. Now let us identify the reason why and how magma rises. Um, First one is the density contrast. So magma rises faster when the difference in density between the magma and the surrounding rock is greater. Naturally kasi, ang magma natin is less dense as compared to the rocks present in our crust and mantle. Pero kapag mas higit, mas malakas yung difference ng density between the two materials, mas mabilis magra-rise yung magma mula sa kailaliman ng ating planeta. At deeper levels, magma passes through mineral grain boundaries and cracks in the surrounding rock. So, unti-unti, it will try to seep through these cracks. Now, when enough buoyancy and mass, ibig sabihin, tama na yung amount ng magma at buoyant na rin siya, masyado nang mataas yung difference ng density ng rock layers and magma, then there will be no choice kundi tumaas yung magma. It will rise. Now, depending on the surrounding pressure and other factors, the magma can be ejected to the Earth's surface or rise at shallower levels. So kung wala namang obstruction na mangyayari at tuloy-tuloy yung difference between the density of the rock layer and the magma, then ideally, it will reach the surface of our planet. Pero kung magkakaroon ng similarity sa density ng rock layer at ng magma, ang idea is that the magma will just stay in here sa ilalim ng crust natin. So this is the same with what I am saying earlier. So if there is no difference in the density, then the magma will just stay there underneath a rock layer and it will solidify. Another reason kung bakit nagre-rise ang magma natin is that because of viscosity. So, viscosity is referred to as the fluid's resistance to flow. So, magmas with low viscosity flow more easily than those with high velocity. And temperature, silica content, and volatile content control the viscosity of magma. If there is an increase in temperature, silica content, and volatile materials, viscosity will be altered. If temperature increases, viscosity of the magma decreases, meaning mas magiging malabnaw yung ating magma, mas mabilis magfo-flow ito from underneath going to the surface of our planet. If there is more silica content in a magma, there will also be an increase in the viscosity, meaning mahihirapan ito mag-flow sa planeta or sa surface ng planet natin. And if there is more water, dissolved water sa magma, then lesser ang viscosity, mas madali ito namang magpo-flow sa ating planeta.